Hi there! Welcome to this webinar where we will be building this hovercraft here together with you guys. Thank you so much for joining us. It's a great pleasure to have you. We will build it first and then we will start doing the coding, and we will try to make sure that everyone succeeds at both building and coding this, and make sure that you by the end of this are drifting around on the living room at home. We're going to use normal tools, so if you haven't gotten the tools ready yet, please do so. We are going to use a glue gun, but the rest is really normal tools like scissors, knives. Yeah. And what else do we have here in this box? Yeah, we got a small screwdriver, and we got carpet knife here. So you can bring that out if you haven't already gotten it. I'm just getting told by my partner here in makekit that we're going to start with the coding, and then we're going to build it afterwards. So without further ado, I think I will introduce Henning Pedersen, who will do this. He's, after all, the expert on all of the makekit products, really. Yeah. So Henning, come on down. I will change seat with you, and we'll start in just a few seconds.
Okay guys, thanks for joining in, and today we're going to go through, I think, the most complicated part, which is the coding part. Can you guys give me, if any of you guys have not built the hover bit already, if any of you have not assembled it, can you please let me know? Because I think that many of you probably have built it, but also probably some of you have downloaded the code directly, which is the easiest way to start. So if any of you have not assembled it already, please let us know in the chat. Because now we're going to go through the code, and what we're going to do is to create the code for the remote control. So this is kind of a code that we will do from scratch. Kind of just hold it on volume down. Yeah, so it's from scratch. So we will actually make this remote control with just the microbit, and we will use the display in a very clever way because we have a limited resolution display. And we will go through the brilliant makecode editor, and we will send some data. So let's start. I don't know how many of you are familiar with the makecode editor, but what we will do is we will go to makecode microbit.org. Yeah. So that's makecode.microbit.org, and this is the main editor that is made by the Microbit Foundation, and this editor is one of the great things about the microbit, because it keeps getting better and better. It's really easy to use, and it's very flexible. So you can start with simple code in blocks, and then we can advance to JavaScript or Python and actually learn those languages from block coding. So today we will be working mainly with blocks. And first I will just show you a little bit of theory. So for the hovercraft, it's all based on a vehicle that can move forward. So it has propeller blowing in this direction, and it also has propeller that inflating some kind of skirt or pillow. And the thing is, so how can we actually control this vehicle? There are three things we need to control. That is the air that is being blown into the pillow, and then there is the forward thrust. So that's the propeller in this propeller here. This will define our speed, and then we need to steer. So we need to be able to control the rudder. See if I can go to the camera 3. So if you see the rudder, it decides how we turn, if we go straight or if we turn. That's all about the rudder. And we will mainly be controlling the speed, forward speed, and the rudder. Yeah, so the principle of the skirt is that air is being blown into the bottom of the skirt, and there will be a little tiny gap between the floor, the ground, and the pillow, which will remove friction. So the idea is that you remove the friction. So we remove friction and it flows very easily around because the friction is gone. So yeah, just a quick introduction on the microbit. So we will be using a lot of the sensors on the microbit for this code. You have the screen. You have the screen here, which we can use to show some information that will be useful. Then you have the buttons, and then you have a very good radio that makes this so we can actually remote control what we're doing. So we can make a remote control and a receiver that is working on the same frequency. And this is very easy with microbit. It's easier than probably any other microcontroller that I know of, even easier than normal radio control toys. This also has an accelerometer which can measure angles, and this we will also be using for our remote control. This is a rule called the ART rule. So the ART rule is the 3 values that we need to send from our remote control. We need to send 3 values to the transmitter, to our hovercraft, to the receiver. We need to send 3 values, and that is A, that is arm, and then we need to send the roll or the rudder, and that is kind of the tail part. So that's the rudder or roll, because we call it roll because you are rolling the remote control, but it turns into a rudder. So it's both a roll and a rudder. And then the third letter, T, it stands for throttle, and that's the speed. And this speed will be applied both to the pushing motor and the pillow motor. So throttle goes into both of those. Like a similar, it will increase the speed similar in both those 2 motors. And so when talking about values, arm is just a number that can be only 0 and 1. Arm is just the start and stop. And to like start the motors and stop the motors. And then throttle is the speed, and it can be 0 to 100, so this is percent. And then we have the steering or the roll, and that is actually degrees. And we will be measuring the steering from minus 45 degrees to plus 45 degrees. So those are the 3 core values that we need to send. So let's get into the coding. So we go to makecode.org, as I mentioned, and we select a new project. So I will go to my editor, my browser, and we will come to this window. And here you will make a new project. and you should give it a name. And now you should select your radio channel, and I think the default radio channel is 7. And so if you are driving alone, if you're not like in a class or something, you can just select channel 7. But if you are with more people, you have to select each a different channel from the other people. I will just go for channel 7 now. So I will say hover bit transmitter channel 7. So now I know that this code is for the transmitter. It's for the transmitter. It's not for the receiver. That's a different code. And it's on channel 7 now. So we press create. And now we have the editor. And in the editor you have the block part, the block area. And then you have the simulator where we can actually test some of our code, which can be handy. And if you don't want to have this, if you want more space, you can hide it. And then here we have all the blocks categories, and you have even more under advanced. And today we'll be using blocks from basic and from variables and some logic and some LEDs. So the first thing we need to do is to select our radio channel. That's how the radio works. You simply select a radio channel and then you send some data. I don't know, any questions so far?
Yeah, the only thing is that we have a comment that there is at least one person who hasn't built
Okay.
yet.
Yeah.
That's
Yeah,
good.
we will do that after the code, definitely. In about 1.5 hours from now. Okay, so first we need to choose a radio channel. And I like to do this by making a variable. So a variable is a way to store numbers. So we give our values a name, so we can store them and use them for later. And I will make a variable called radio group. So this will contain our radio channel. And then now I can actually, if I click variables, I can use the set command. So you have set and you have change. Set is to as the name says, is to set it to a specific number. Change is to add or subtract. So don't use change now. We use set. Set your radio group to, and we select our channel. And the default channel is 7. And then now we need to put this into effect. So right now it's only a variable, it's not doing anything. So we will go to radio. So we press the radio block menu and we select radio set group, the very top block. And we insert that under. And we want to set the radio group to this variable. And then we go to variables and we can pick up the radio group as a single variable and we just insert it into the radio group. Now the radio group will be set to 7. So you can say, why don't we just do this and this? But the reason for that is if you change your channel, you actually want to see it on the screen. So we want to do one more thing, because we want to actually show our radio channel. And the reason for this is that, especially in the classrooms, if you have, let's say you have a transmitter and a receiver and they are not talking to each other, you want to know why. And what you can do is that you press the reset. And when you press the reset, you will start again and it will show a number. So we wanted to show you actually radio channel when you switch it off. It's very practical to find errors. So we wanted to show this number when we start up. So every time we press reset, when we press reset, it goes to this on start again. It does this. It does whatever is in on start. So we will choose show number, and this will be radio group. So now we can change this number, and this number will be whatever number we choose. It will be our real radio group, and it will show on the display. So on the simulator here now, we can actually press a button called restart, and it will start. It's supposed to start again. Let me see. I can stop it, and it will show our number. And the point is that it has to show the same number as our radio group is. So if you just enter something here, this will not show our real radio group. So that's why we do it like this. So that's our 3 lines on start. And now we are going to collect the information that we are sending. So remember the art rule. There are 3 things that we need to collect information. We need to kind of define these 3 from our transmitter, and we need to send them all. So we can make them as variables. So we go to variables, and we create those 3. So we have the art rule, so A. So what A stands for, if you remember, that's arm. That means on and off. ARM is kind of from drone language, actually. It comes from flights and disarming and arming. On airplanes, you are actually you're actually arming the emergency doors. So next time you take an airplane, you can try to listen for flight disarm, or they will always say this before takeoff. And it means that the emergency doors are armed or disarmed. But we will just use arm for start and stop. And then you can make the R, and that is roll. And then your third variable will be throttle. Oh, sorry. So now we have arm, roll, and throttle. And now we want to use our remote control to control arm, roll, and throttle. So we have 2 buttons, and we have this accelerometer who will detect our angle. So we want to use those 2 kind of inputs to generate those values. So we can start with the roll value. So roll is when I tilt sideways, I will change the roll angle. So you go to input, and here you have access to all the sensors on the microbit. And you can see there's a lot of things that can be useful later, like light level, temperature, compass heading. Things that can be very interesting to experiment with later, like compass. The compass will give you the ability to make the hovercraft automatically stabilize into a certain direction, so it can actually autonomous change the direction into like north. Okay, so you tell it to go north, it can use the compass to do so. But right now we'll be using the roll angle. So you go to input and then more. And then you have something called rotation. So we pick up this one, and then in the forever loop, we call it. This is the forever loop, and it goes again and again and again, 50 times every second. So it's just repeating on again and again. So we want to do is we want to feed our roll value with the information from the sensor. So we go to variables, and we're going to use the set command again. And we just pick up set. Now it says throttle, so we just change it to roll. So we're going to be setting the roll, and it's going to be set to the rotation, but it's not going to be the rotation pitch, it's going to be the roll. So we need to actually click on the little triangle and select the roll. So now, every 50 times every second, we will be updating the roll value. Okay, so we have the roll, and now we need to change the arm. So the arm is like a stop and start and stop. And for that, I think the easiest thing to do is to use A and B at the same time. So what we found is the most useful is that we use throttle on the both buttons. So if you want more speed, you press B, and if you want less speed, you press A. But if you want to start and stop now, you don't have any more buttons. So what do? You use both. So A plus B at the same time will make the arm go on. And next time we press A and B, we want the arm to go off. So it will go on and off and on and off. So let's try to code that. Now we go to input again. So this is again where we find all our sensors and buttons. And we will be using the on button. And we will change this to A plus B. So now we have something that will happen when we press both buttons at the same time. And then we're going to use some logic. And then the idea is that if the arm is 0, we want it to be 1. But if the arm is 1, we want it to be 0. So every time we want it to change. So if arm is 0, we want it to be 1, right? So we need something called comparator. So first I was picking up the if block, and then we need to compare it with something. So the comparison block, you insert it into the if block. If arm is 0, then make it 1, right? So set again, you set the set command. If arm is 0, set arm to 1. And then if arm is 1, so if arm is 1, set it to 0. That's how I thought the first time I made this code. So what we can do now is we can actually test it already. So we can go to basic, show number, and we will put this in the forever loop, and we will show number arm. Let me first remove the bottom part here. And I will enable the simulator. So now it's showing the arm value, which is 0, because any new variable is always 0 in the beginning. And then I will press A plus B in the simulator. So there's a button here where you can actually test the A plus B. And now it's supposed to be 1. And now we see it changes into 1. So now it's gone from 0 to 1, which is what we wanted. But we wanted next time we press it, we want it to go back to 0. So this is what I did the first time I made this code. I just had another. If arm is 1, set arm to 0. So okay, we go back again. Just the opposite of this one. So let's try how it works. I press the A and B, but the problem is nothing happens. And the reason for this is that it goes here, it's 0, it makes it 1, and then immediately it detects it's now 1, it goes back to 0. So we need to be a bit smarter about this. So what we will do, we will use the else command. So if we press the plus sign here, you will get the else, and then what will happen now is you will never do both. You will never do this and this at the same time. So they're kind of excluding each other. If arm is 0, set to 1, else, it means that if the arm is not 0, so it means that it has to be something else, like 1. So, okay, so it's, for example, it might be 1, set it to 0. And now we can test it again. It becomes 1, and next time it's 0 again. So now we have the arm and this arm, and this arm again. And I will now remove this show number because it will kind of try to take over the display, but we want to use the display for something else later. So I will delete it. I can just press backspace on my computer, or I can right click and delete it, or I can move it over to here and it will become a trash can. So it's your choice. Okay, so we have roll and we have arm, and now that we want the throttle. So as I said, we will use the buttons again. We will use button A and B. So we go to input, on button, and we can grab 2 of those. And now you will notice one of them are grayed because you cannot have 2 similar button blocks at the same time. But we change this to B, and now they are both active and can be used. So when we press button B, we want to increase the speed, or at least that's what I feel more natural, because for me it's more natural to have less speed on the left and more speed on the right, but you can switch it if you want. So on button B, we want more speed. So we want to increase our throttle. So now we will be using the change, because change is adding and subtracting. And I like to use the number 5, but you can use another number if you want. But every time now we press the button B, you will increase throttle by 5%. If you have only 1 here, you will need to press the button a lot of times if you want to have a good speed, because a good speed could be like 50 or 80 or 30. So imagine if you were to like press like 50 times to get a decent speed, it will be a lot of clicking. So let's make it a bit easier. I think 5 is a good number to start with. You can even use 10. Yeah, 5 is pretty good. And then now I can actually duplicate. I can right click on it, or I can just press Command C, Command V, or Control C, Control V, copy paste, and insert into the A as well. But here I want it to be negative. I want to be less speed on the A button. And now we can actually test it by the show number again. Show number and put it into the forever. And we can show number throttle. So let's see if on the simulator if it works. We press B, it's 5, and then it's 10, then it's 15, and it's increasing. And then, yeah, you have to give it some time because it's kind of needs time to scroll. 40, 35, and so on. So we know it's working. Okay. Another thing is that is really practical is that, okay, imagine if you drive and your speed is 35 and you want to stop, you press A and B, right? You press A and B to stop. But the thing is that when you want to start again, you cannot start with a speed of 35 directly. You have to start from a low speed. Because the hover bit, the controller on the hover bit will not accept any speed above 0 when you're starting. So you have to start with a 0 speed. So what we need to do is to actually zero out. We want to zero out our throttle when we start. And when do we start? It's when we set arm to 1, that's when we start. So in here, we want to set throttle to 0 because we will be zeroing out the throttle. Or we can even have it here. It doesn't matter because every time you press every time you press A and B, you are either starting or stopping. When you're stopping, you also want to set the speed to 0. And when you're starting, you want to set it to 0. So we can just have it here, set throttle to 0. And you start from a scratch, okay? You start from 0. And one more feature that we really want that is really helpful, and that is the emergency stop. And the emergency stop, I will show it to you right now. If you're driving and you're about to hit something, you kind of can forget about the A and the B, like in the rush of the moment. So what you will do is we will use the motion sensors, the accelerometer, to detect shake. So what we will be using is just the shake. Okay, so you increase the speed. Sorry, you increase the speed. You panic, you just shake it, and it will stop. This is a really useful. This feature is actually quite useful. You will probably be using it a lot. So let's code it, and it's quite simple. We only need to use the onShake. So onShake is in the sensor blocks, within the sensor blocks. It's detecting rough movements, rough motions. So we pick it up on shake. And so how can we stop the hovercraft easily? We need to set arm to 0 and throttle to 0. Then that's the full stop. So set throttle to 0 and set arm to 0. That's why I love makecode. It's so easy to do really clever stuff. Just 2 blocks of code, 3 blocks, and you have a very useful panic feature. Okay, so now we have 3 values. We have the arm that can supposed to be 0 and 1. We have the throttle, which is 0 to 100, and that's percent. And then we have the roll, the steering, which is degrees. And now we want to actually use the display. So let's try to use the display here to show if everything is working. So we're going to be plotting some LEDs to see if things are working. So let's go to makecode again. And LED. So the LED, we can change the pixels on the screen. Let me show you. So we have 25 pixels. 25 pixels, 5 pixels for 5 rows. And now first remember to remove the show number, because this will try to steal our screen. So make sure to put this out. You can delete it or you can just leave it gray. And then for LED, we press LED and we use plot, and we'll be entering X and Y, and that is the coordinates. So we can just try plot 0.0, and the simulator now is supposed to show us the result. And it's now showing nothing because it's plotting where the number is already. So let's clear the screen first. Clear screen.
I have a question.
Yeah.
Question from one of the viewers. Can you please update the shake code to use ARM as the secondary variable? Did you get that?
Oh yeah. He spotted a mistake. Very good.
Yeah.
Yes, you're correct. Arm and throttle, that's what you want to set to 0. Okay, so now we see that our plot is resulting the LED on the top left. And if I press inside the number, I get a slider and I can choose the coordinate and just try something else. And you see I changed the X coordinate, and now the dot is here. So this is the X-axis. And if you're familiar with coordinate systems, you know that X is going this way and the Y-axis is going up and down. This is like standard statistics or graphs, or yeah, it's a common way of thinking. If you hold the mouse over LED, you will actually get the coordinate for that LED. So the bottom right has the coordinate 4.4 and the top left has the coordinate 0.0. So what we want to do now is we want to plot the roll, the throttle, and the arm in just this small display. So we can start with the roll. I would usually, for me at least, I would say that the roll could be in the middle here. It could be one dot that is moving according to a roll. So we will be changing the X value for this. And the Y value I will set to 2, because then it will be on here, and it will go this around this axis. And if we set it to 0, it will be around the top axis. And if you want, you can have it on top if you want, but I prefer to have it here in the middle. So I just set 2, and then now we need to input our roll value in here. The problem is that our roll value is between -45 and 45, but our display can only understand a number between 0 and 4. So we need to do a little calculation, or a little like scaling. We need to kind of stretch our numbers down to a number between 0 and 4. So we have a number now between -45 and 45. We need to squeeze them down to a number between 0 and 4. And we can do that easily with something called map. So if we go to math, there's something called map. And we insert that into the X. And map will be asking, okay, so what do we want to map? We want to map the roll. And we go to variables, we pick up our roll value. And now it's asking what's the lowest roll value we can have. And that's minus 45, right? And then it's asking what's the highest value we can have. That's 45. And then it's asking what should it output as lowest value. And that's this one. And that is the 0, because x will be 0 on the very left part. And then it's asking the maximum value, and that is 4. Because 4 is the rightmost pixel. So now it's taking those numbers, crunching them down to something between 0 and 4. And in the simulator now we can actually test it. So we can move our mouse over and tilt the microbit, and we see now that it's actually showing the change of this angle. So it means that it's working. So if you did something wrong, maybe you forgot to switch the pitch and roll, you will see that it's not really working well. If it's like this, you know you did something wrong. So it's supposed to follow the mouse arrow. So like that. Okay. So that's the roll. And then the throttle. I like to have the throttle on the left side as a bar, or something that is climbing upwards. So the more throttle we have, the higher I want this kind of bar to be, or dot. I want the dot to climb higher and higher, the more throttle we have. So we're going to do a plot again. And I will be set x to 0 because I want it to be all here. I want the x to be 0 all the time because I just want to change the y-axis now. And the y-axis, I want to be the throttle. And then again we have the problem that throttle is a number between 0 and 100, but in the screen we can only use 0 and 4. So we use the map again. And now it asks again, what do we want to map? And now, as you might know, that's the throttle we want to map. And the throttle's lowest number is 0. And the highest number is 100, right? And then it's already proposing 0 and 4. So we can try it and see what happens. So now we actually have the throttle LED on the top left here. And if we increase the throttle, it's moving downwards. So it's kind of working, but it's kind of climbing the wrong way. So we need to change a little thing, change to reverse the whole thing. So maybe some of you guys already thought about it, but what we can do is simply switch 4 and 0. So to our lowest value will be 4 and the highest value will be 0. And now it starts from the bottom and it's climbing upwards. And now we can even test okay, is our shake working? Because shake is supposed to set throttle to 0, right? And we can press shake in the simulator and it goes down. So we know that shake is now working because it made the throttle go down. And then we can even try the A plus B. And we see again throttle goes down. So we know A plus B is working as well. And now we want to display arm. And I like to use the topper left dot for this, but if you have other preferences, if you want to show the arm in another way, you're free to do that. But I will just use plot 0.0 for the arm, but I don't want it to be on all the time. I just want it to be on when the arm is on. So if arm is 1, then I want it to be plot. And the good thing about coding is that you can just, it's so logical. So if arm is 1, I want it to plot. So we go to logic and we choose if. And I can actually do it very simple with just like this. If arm, that's all I need to do, because if arm is the same as if arm is not 0. So if arm is bigger than 0, then it will do something. So this code is actually similar to, I can show you what it's similar to. It's similar to actually this, or it will be the same as this in practical. But it's just a trick. It's kind of more efficient. You can just do this. See, it's easier when you know it, so we'll just use it for now. And then if arm, and then I will take out the plot and put it into the arm. The arm if block. So now we can see there's no LED on the top left. If I press A plus B, it goes on. And I press A plus B again, it goes off. I can test the shake, and you see it goes off when I use the shake. So if you want it to be somewhere else, you can just change the coordinates. If you want it top right, or if you want it whatever you want. Even if you want more, you want to be 2 pixels, or 10, or 5. You can do whatever you fancy. Okay. So now we have the display, we have the roll, we have the throttle, we have the arm. And now there's only one thing left for the code. And that is we need to actually broadcast these values over the radio. That's the last thing we need to do. Let me see if we can show you. If you see here in the picture, you have the transmitter. This is what we're coding right now. It's the one on the left. And you see the radio signal goes from it. Right now there are no radio signals going from the microbit. So we need to broadcast our values. And for that we'll be using the radio. So we'll go to radio. And we'll be using something called name and value. No, sorry, here. Name and value. And the reason we were using this one is that we need to send a tag together with our value. We need to send some kind of name tag, because the receiver needs to know what value it's getting. So in the bottom of the forever loop, we will be sending our 3 values. So as you remember the art rule, we can start with A, and for this to work properly, we need to make it, we need to tag it with a capital A. So make sure you don't use a small a. This will not work. This is case sensitive. Have to use a big A. And then the number we will send is our true arm value. Okay, so now we'll be sending the letter A and the number for arm. So on the receiver part, it knows that this is the arm value. And then I will just copy and paste it. And then the next letter is, as you know probably now, the R. And that is roll. And then the last one is, let me just, the last one is T. Capital T and throttle. Okay, so now it will all those 3 will be broadcasted. And now I think it's about time to transfer the code to the real world, as to speak. And so I will be connecting the microbit to my computer. Har du en minus-B? Nei, jeg har den her kanskje. So, let's see. I will be connecting. I have my micro USB cable here. And kan du se om du finner en annen kabel? Jeg vet ikke om jeg får, om den her er sånn. Yeah, I'm just asking Steinar to give me another cable, because sometimes your USB cables are only for charging and they don't carry any data. Thanks. So let me try with another. Oops. Yeah, oops. Yeah, and the whole thing is that you need to get this microbit drive on your computer, right? So when this shows up, you know that you have a connection to it. And now I can simply press download. And sometimes it asks for the folder. I will just select the microbit drive as a destination and hit save. And now you need to watch the back side. Watch the light on the back side. It's supposed to blink when it's transferring. So if it doesn't blink, then it's probably not transferring. Okay, so now it's transferred, and the first thing I want to do is to reset. So I will be pressing the reset button, and I want to see if my radio channel is shown. So it's starting up, and it's showing the number 7, which is my radio channel. So I know now that this was working, and it's on channel 7. And now I want to test the roll. So if you did everything right now, the center dot is moving the same way as our roll movement. And then I will try the throttle. So I press this, and you see now it's increasing. Oops. Oi. Oh no! I became a Smurf. Yeah, so you have the throttle. And and then let's try the shake. So we make the throttle high up. Okay, and then shake. And now it's gone down. So it was working. And then the arm, I press both. And you see now those 2 buttons that I made, they are on and off. Okay, and the next step now is, I don't know, okay, I will take you through this as well, because we need to have the right kind of code on this one, and this is another code. This code is much more advanced, and so we will not like really go into detail with it, but if any of you are interested, we can talk about it later today, like briefly, but now I will just show you how to put the right code on this microbit. So we go to the docs. So as you might know, we have a docs page. That is all the instructions for yeah, all the instructions for you guys, for your, everybody that buys the. Yeah, he will even, it will be available in the chat as well. And yeah, so the docs is where you always go to find the instructions. And then you select Hoverbit. And here you will find instructions and also like fun projects and things, do more things. Like the fun projects that you do for when you already have the Hoverbit kit. So this, and here we will add more features and more fun things to do, as we go. So we will be posting more stuff this autumn. We are working on a couple of fun things. The catamaran, for example, will be available for 3D printing. And this weekend we are actually working on a boat as well that you can print. So there's many fun things that's in the making here. And you have also video tutorials that will go through the building step by step. And we will go through the building today as well. But here you can always go back and see like the tutorial for whatever part. Like you have the unboxing, you have the controller assembly, you have the wiring, you have all the chapters neatly like divided. But right now we will need code for the hovercraft. So you need to download this code. And this is a hex.hex file. And don't download it to this one. You have to download it to your receiver. So that's the other one, the receiving microbit. And I have plugged it in, and I can actually download it directly from the website to the microbit. You can see it's blinking now, but also you can of course download it to your computer and transfer it later. And you can even open this hex file in makecode. Code for hovercraft. I will just show you an example. I just downloaded it to my download folder. So if you want to explore this, you can go to a new window on your web browser. And sorry, makecode. So okay, I keep my original transmitter code here, but I can make a new window and I can import the file that I just downloaded. And this is the whole code that will be going on the hovercraft. So this is slightly, actually quite more bigger. But if you guys want to explore it or have any questions about it, you can explore it. And if you need to change the radio channel, this is a very important part. So if you're driving with someone else or in a classroom, you have to choose, different radio channels. Every user have to select their own radio channel. So then you will go here and simply change this number. And as you remember, this will take this number and it will show it on the screen, and it also use the same number to set the radio group. So we only need to change this number to whatever you choose for a channel. You can choose anything between 0 and 255.
One thing, can you show which file to download one more time?
Yes.
Yeah.
So you go to docs, and then, or you can just go to makekit.no/hoverbit, and then the file you need is code for hovercraft. That's the one you need to put on your hovercraft. So you can download that directly, or you can open it here and then download it if you want. And so some, like, if you just want to like change like a simple thing in it, you can change low battery icons. And so here is actually the low battery icon, and it will show up when your battery is drained, and you can change it to whatever you want. And here, this is the charging animation. So what this is doing is making a little animation, and it's supposed to show battery that it's being charged, but you can also change this if you want. So if you want to play around, you can make another animation here. And outside of this, I don't recommend to change a lot unless you want to change the servo. So if you are familiar with the servos, and you can actually control your servo number 2 however you want by changing this value. If you want to have some kind of mechanism or grabber or some special feature like adding a servo, you can control this here by changing this number. And then here, yeah, this is also like if you're like advanced, you can actually send data back here. So now it will be sending the battery voltage. So if you're familiar with battery voltage and what it means, you can send it back to your receiver, and the receiver can have a battery gauge to show, you know, how much battery you have. Or you can send the acceleration if you want. But this is more like advanced, and it goes to actually telemetry, which will be a separate video that we will be releasing. And that's telemetry is like everything that is going on everything that's going on here, you can transmit back, and you know, you can have temperature, you can know the battery, you can know the acceleration as you're driving.
So we have a question. This is from Michael. Are you going to talk about the data that you're sending to the add-on board? And the reason,
yes.
Yeah, okay, you are going to.
The reason was what?
Yeah, the reason is that he would like to try to keep the hoverbit motor running pretty fast while using the throttle to control the forward motor. So, you know, that's the context, really.
Yes, I understand the issue. Because you want to be able to control those two motors separately. You have the fan motor and you have this motor. The challenge with this is that this controller is based on a drone controller. And it's a modified drone controller right now, but it doesn't really have the option of separately controlling each motor. And we really challenged, because we have a developer, his name is Dominic, and he's one of the guys behind the Clean Flight system and the racing drone system. He's really like one of the founders of the racing drone control boards. And because it's made for drones, there's not like really a feature when you can do it, but what you could do is you could change the pitch value. And the pitch value would probably influence your forward throttle, but you would probably need to install Betaflight and to tweak around in there. So I wish there was like fan motor and throttle motor, but it's unfortunately that's not how the control board works. So you see here that we have the pitch, we have the arm, we have the roll, throttle and the yaw, and this is actually stems from drones. On the good side is that you can add two motors and you can print a frame, or if you wanted to be a drone, it will easily become a drone. So in that way, it's like very versatile, but yeah, I wish there was a better way to independently, you know, control motors, but currently there's not a good way of doing so. But yeah, I can show you, if you want, you can go through the beta flight if you have time. I can just show you how actually the control board works.
Maybe we can do
Yeah.
it later in
Yeah.
a different setting.
Yeah. Yeah, we have more to do today, so yeah, I don't know if it's. But anyways, the next step now is to verify that we have a connection, and I can disconnect and switch it on. And the idea is now is to verify if you have steady connection, and the idea is that the center dot is supposed to move parallel, right? So if you did everything right, this will move accordingly. And now we know that they are on the same channel. And then let's see if we can, and yeah, and we know that it's working like this. Sometimes it's like a common thing to have this cable wrongly placed. So make sure that this servo cable has the darkest color on the bottom, right? So if you imagine like a sunset, you have the soil, you have the ground, you know, the darkest color is lower, and then the orange color, if you imagine it's a sunset, you have the orange color on top, and then the red in the middle, and the brown is in the lower, is under, right? So don't flip it, because if you do, then the servo will not work. But now it's following my movements. And another thing is that when this is flat, the tail is supposed to be not like this. The tail is supposed to be squared like straight. And now I see it's kind of straight, but it's not perfectly straight. And then what you can do is that you remove the motor. And then, oh, that's very hard. And then you lift it up and you flip it a bit, and then you screw it on. And on this one I'm using the screw because there is a screw that will secure it. So I need to unscrew this, but probably many of you don't have it on because it's not like strictly necessary. But then I'm lifting it up so it's loose, and then straightening it out, and then screwing it back on. And you might notice that there are two wedges in the kit. There's one like this, and one that is more thin, that without the nose part. But this is like the latest one, so I recommend this. It makes it more stable. It makes this motor more stable. See, now it's more straight. It doesn't have to be perfect. It should be like 5 or 10 degrees. It's okay. And then there's another thing that with this board, because it's based on drone technology, it has gyro sensors. So if you move it sideways, it will actually move the servo, and this is actually an automatically stabilization. This makes it a lot easier to drive or drift, as we say, because it automatically corrects the angle. So you will never get into a spin. You never, with the hovercraft, without this, the hovercraft would easily go into a spin. But because it uses the sensors to correct, it makes it a lot more stable and a lot more fun to drive. So this is the code, and it's all all I went through now is available on the document called How to Code the Transmitter. On the docs, How to Code the Transmitter will take you through everything that I did now. Any other thing you guys would like to see before we start with the building part? Any other questions or things that didn't work, or any other needs, concerns?
No, I don't think we have any big questions now. But are you ready to go on to the building right now, or is
Yes.
there anything? Yeah, because maybe we should take.
Or you?
Yeah, maybe we should take like 5 minutes.
Yeah.
Before we do
Okay,
that.
so I would just want to, if you guys want to build now, make sure that you have the screwdriver, scissors, knife, cut something to cut on, like cardboard or something you can cut on, and glue gun. Or we recommend like contact adhesive. Contact adhesive works also very well on plastic. Other glues might work okay as well if you don't have it. Then you need a marker. And then you need either the original hoverbit box. And if you already cut the box, you can just take some cardboard. But try to have a cardboard with like a medium thickness. This is about 3 millimeters thick. So it's about the same thickness as like the screws here, because the screws are also 3 millimeters. So try to find some cardboard. And you need the bag. And so we use zip bags of 15 by 20 centimeters. And you can have slightly different size on the bag, but the original bag or a similar sized bag is the best. So you go grab those stuff, and then we will be back in 3 minutes. Yeah.
Something like that.
Yeah. 3 minutes. See you guys.
Yes, now we are back and we will start building the hovercraft pretty soon. So with me here, Henning is actually cutting up an old box that we have. And the reason why we are doing this is that, so we have this one, but for this exercise, we will use the template. Now this template is something that you have gotten a link to it in the mail that you have received, and it's also on the Hoverbit page, which is under the docs file. So here I will be using this one instead of cutting out the box. Of course, if you have the box and haven't already built it, use the box. So now I think that, yeah, the link should also, the link is also in
Docs.
it's in docs, and you find the link to docs in the comment section in the stream. So without any further ado, I think we can probably start. I think I will start by unboxing first. So we have all the stuff we need there. Okay, just move a little bit of space here. We try not to destroy anything. So maybe I can do this under here.
Yeah.
Let's see. So we have plugged this in, right? Good. So once you open this one, you will also find this section here, which is kind of a gratulation, but at the same time be aware that when you're opening it, be a little bit careful, because underneath here you will find cutouts, like you see here. So these ones you can cut out from this board. So here you find all the stuff really that you need. And here you have, in the bottom here, you see the base plate, which you can cut out. Now we will of course do this in a little bit different way. So I just want to show you this, show all the parts here, and now we can go to cutting it out. Let's see. So if you have this sheet here, Henning, there is a ruler underneath.
Yeah.
Nej, där står. Yeah. So there's a ruler here, and the reason why I want the ruler is that here you see 20 centimeter for you to measure. And the important thing here is you want to do this to check that the scale is okay, right? So here we see that, yeah, it's 20. Good. Then we can proceed. Do we have some glue? Some glue to glue on? Okay. Like normal glue.
Normal? Yeah, sure.
Yeah. So here what we can do is that we can actually glue this straight on to the cardboard box, if the cardboard box is big enough, and this one really is. So what I will do is that I will try to glue this A4 page straight onto the cardboard. If I can get some normal glue. I hope we have it. I think we do. Otherwise, I hope that you have enjoyed this broadcast so far. And of course, if you have any question, really now is the time to ask them about, building, coding, other forms of use as well. So don't be shy. Come with your questions. Now, here I gotten the glue, and we will proceed on to basically just gluing this page straight onto the cardboard. That makes it a little bit easier for me, at least. Let's see, we do it right there. And here I even get, you know, the design and everything that you really get with the ordinary box. But of course, since I printed it on white paper, it's white. So there's the difference. For the circular part here, I'm going to use a scissor, but you can of course also use a knife if you want to do that. So join in and cut out your own fleet as well. I think I will switch actually to the knife, probably easier. And one technique that you can use here is, I don't know if there is anyone out there who have done gyps, what's gyps?
Plaster.
Plaster walls. So you can use basically the same technique here. That means cutting a few times. You can cut like the top layer of the cardboard first, and when you're done with that, you cut the rest of the layers afterwards. This was cut straight to the edge here, so the printer couldn't get the outer shape really good, so, but I guess that's okay. Let's just cut all the way one more time just to make sure that we have gotten everything sorted out. Now, if you're going to use a knife like this, you should really use something below it to make sure that you don't harm the table or whatever you are working on. So let's see if I can get it out. Should be quite okay now. Then you can turn it around and just make sure that it's really loose enough to get out here. I see there is a couple of spots here that should be, there we go. There. Now I'll do just some finishing touches. I can do this with the scissor. Get rid of the extra stuff around here. Well, yeah, it's pretty good, I think. Pretty good. Good. Now we have done that. We need to cut out this part here as well. So basically use the knife in the same way. This is actually a super nice thing to do with your kids as well, you know, teaching them how to use different types of tools. Just remove. good enough. Then I just cut a little bit from the other side here. The cardboard I'm using here is actually quite thick, so it's a little bit difficult actually to come all the way through. But that's all part of the experience. See, there we go. And I think it's almost loose. There. And then we have our fleet. Now we need to also stick something through here, because here we are going to fasten the base that you see here. So we will make some holes here. Now I will just use the knife just to come a little through the first layer. Let's see. This didn't lock at all. And then I use a screwdriver, really, to just punch through here. And then we have the fleet ready. I think I will go all the way through here, really, just to make sure. So what I do is really that I stick this, so I basically see the knife sticking through on the other side. That way I can, that way I know where it is placed, and I can actually use the screwdriver from this side as well, just to mark the holes here. There we go. That one is finished. So when we have gotten this one, it's time for doing these ones. Cut them out. So you can choose which one you like, or of course you can make something on your own. One of the things that might be quite important is the size. So you don't want to have it too big, and you also don't want to have it too small. So this is like a size that works, but if you want to be creative, just make something on your own. That's a super cool way to modify it. So now I will cut out this one. I think I will go with the number 7. Well, I'll do the number 7 today. So basically the same thing as we did with the raft. I will do the outer lines here. Let's see.
Kanskje nevne at den halefiden kan man lage litt som man vil da.
Yeah, like Henning just mentioned also that you can do this the way you want it to, but in this video of course we will do the way it's described in the template, but be creative. This is a chance to really do something special with your craft that maybe separate it from what other people are doing. So as I mentioned before, the cardboard that I'm working on here is actually quite thick, so it's a little bit hard to get through all the layers, but maybe that works for the best, because then I work a little bit slower than I would otherwise. Let's see if it's all the way through everywhere. No, it's not. I just do this freehand. There's a little part here as well. There we go. Now it's out. And I think I had something, you know, now we have one side here that is that has the graphics on it. If you are using the kit, you will get both sides with graphics. But here you can, you know, be creative, do something cool on your own. And as you can see, this is like double cardboard, so really excessive. But that's like part of the experience. Now it will be fun to see if actually this works. So the first thing we need to do is basically assemble the card the way that we have here. So what you want to do is that you want to screw these in from this side, and then on this side here you want to attach these what is missing?
knurled barrel nuts.
Knurled barrel nuts.
And make sure they are tight, because they are supposed to lead electricity through here. So they need to. You can't have any slack. They have to be tight.
Yeah. So maybe I will. Do we have neb tongue or something?
No, we don't need it.
I just want to show.
Just make sure. I can show you actually with my fingers. You have to make sure it cannot wiggle. So you just like now, if it wiggles, you will feel that now. Okay, you can even hear it if they're wiggling. So make sure they don't wiggle. You should be able to do it with your fingertips, because it's not like you're not using brute force. You're just tightening it. Finger tight, what we call it. So now it's not wiggling anymore. So just this is like very important. Okay, and then we cheated a little bit, so we already added those screws. This is very step by step in the instructions already, so we don't need to do everything like from scratch now. You will find these are the only white ones, screws, and just make sure you do this before you put on the microbit, so you don't. Because now you cannot remove them, you cannot add them. So make sure to do this first before you put this on. Yeah,
and make sure that you do this also the right way. That's like you want to see, when you see all this stuff here on the airbit board, you also want to like see the barreled nuts here, and you want to see the top of the white screws right here. And like Henning said, everything should be tightened so it's not loose. So while you do that, I think I will just prepare a few things here. So what we have here is that we have the frame, we have a few nuts. Oh, here we have a bunch of stuff going on. So we have the servo, we have a few motors here. This one, this is a neat little tool that you can use. The usage of this one is when you come with nuts like this.
Yeah.
So you can use this for a number of things. So this is actually online, which you can print if you want to.
Let's go to marker.
I think I saw it.
Let me just show you just a quick, like if you don't want to use our tail, if you don't want to use this, you can just freestyle it. So you just draw something that looks kind of like a sail or rudder or something, and approximately this size, and then you can write, you know, you can make some decorations or whatever, and then just
That's gonna be nice.
And this is maybe easier in a slightly thinner cardboard, but the idea is that it has to be a certain size. If it's too small, it will not really have any effect. And then it's supposed to go into this holder, so just make sure that it's stuck like this. And it's snugly. Yeah, so this works.
Yeah.
And you can keep changing, keep redesigning, play, have fun.
Yeah, and if you do something cool, we also recommend sharing it on the Facebook page.
Yes.
Which is
We just you have locked the link in now.
yeah, the link should be there on the comment section, so you can check that out. Just clean this up a little bit before we start assembling the board. So when you start, we want to use this one, Henning, right?
Yeah.
Yeah. So when you start, then you have to assemble this one as well. So what I do with these small nuts here. So what you want is that you want the 0, 1, 3 volt and ground to be connected here. So then I will start assembling these screws. Now, you know, I have quite, my fingers aren't that nimble, so so this is. So this is kind of a nice exercise actually to get a little bit of training, and this is when this tool here comes into picture. So with this tool I can just screw this one in, and it's the same thing here, that you want there to be a connection. You know, you want there to be a connection between the microbit and the airbit board. So make sure that, you know, you screw it nice and tight, shouldn't be any wiggling, but you don't want to like over exaggerate either. If you like do this with a steel tool of some kind, you might break the board. So make sure that you like, it should be finger tight, but not more than that either, because you actually can break the board. So when that is finished, we can start placing the boards onto the frame here, which is of plywood. Let's see if I have some extra nuts. Yeah, there they are. It's important to do this in the right order, because if we were to place this board now on the raft itself, we wouldn't be able to reach these screws here at all. Let's see if I can get this one on there. There we go. Now I can also use this tool. Of course, you can just use your fingers. But since I have this, I've already printed this out on our 3D printer. I'm just going to use that one for convenience. This one is just supposed to like stick in there. And now we can start adding on this part here actually. So what we can do now is that we can place these parts in the right. Let's see, this one was pretty hard to get in there. This one's stuck nicely. This actually sticks so good, so you don't really need anything else. But you're supposed to have this rubber band here. This small rubber band supposed to go between. Oh, there it broke actually. Are we sure this is the right one, Henning? This one?
Yeah, no, it's a substitute because
Yeah.
we're out.
Yeah, because this one won't hold.
Okay.
So then we know that this won't hold. So while Henning get the ones that you have gotten, I hope we have anything left in there. But this one actually sticks on nicely. So I really don't think I need anything else. I noticed that it was quite tough to get in here. You might experience the same thing. Just make sure that you wiggle it a little bit. There we go, much nicer. So this is the way you want it to be. There we go. And now we can mount the servo. So I'm taking the servo out of the package here. So what you want to do here, let's see. So what you want to do here is that you want to have, where is it? There it is. There's the rubber band. So what you want to do now is that you want to have this one going underneath here. If you saw that, then you just stick it in like this. This also should fit quite nicely. So it actually holds now, and then you can mount the rubber band onto it. Make sure that you pre-stretch it far enough. And there we go. And then we can take this servo horn here. Just empty out the whole package. Then we're going to use this one. Just place that on there, so we know where it is. Is there any comments, Henning? I can take this one. Which way does this go, Henning? This way?
Yeah.
But maybe we should do this after we have mounted that one.
You can mount it to the raft first.
Mount what to the raft? Yeah, the whole thing?
Yeah.
Yeah, okay. Yeah, then we do that. We take, now what Henning said was that we want to mount this whole structure here onto the raft itself. So then what we do, we have these screws here. These are the long ones, right? So what we want to do is that we want to place them like this. This is why I pre-cutted the holes, really, to be able to get these screws straight through. Now it will be interesting to see, because this cardboard is so thick, if this will work the way we want it to. There we go. And then we have these spacers that you have gotten in the package. So we want to have 2 of them, right, Henning?
Yes.
Now
Usually you want to, but
yeah,
if the cardboard is really thick,
like,
then you might use only one.
Yeah, we'll see if it works with 2 for us. We might need to use only 1 because this cardboard is so thick, but I think it might work with 2.
Må litt framover.
Yeah, I think it might work with just 2. No, I don't know. I regret that. It won't work with 2. Let's see if I can mount all of them correctly now. There we go. Every one of them is snugly in place. And then we just screw this tightly. So the cardboard here was actually so thick that we couldn't mount all of the screws. Let's see, do we have one more? Should have one more. Do we have some more nut sending somewhere?
Yes.
So now I see that I actually have done a slight mistake as well, because the servo is attached and then I can't really get to this screw, not this screw here. But then it's only a matter of removing this for a second and we will be able to mount the last ones. Let's see. Did this in slightly wrong order. Let's see if I can. There, it's just, I think it's stuck on there.
Du må vise litt bedre i kamera. Sånn.
Quite tightly here. There we go. And then in the front, like this. Then I use the tool just for convenience.
Kanskje ta lime posen nå.
Yeah. There we go. So now, before we do anything else, to be able to lift this off the ground, we need some air, right? So what we have this bag here. Now, if there is a possibility to glue this the wrong way. So if you do this, don't despair. These are bags you can get at your normal convenience store. So it should be easy enough to find. So what you want to do is that you turn it over like this. So what you want to do is that you want to mark where this hole here is going to be, because you need to cut through it. Let's see.
Tenker hvis du tegner her først. Skal jeg vise deg, eller?
Yeah, do you have some pointers, Henning?
So what I usually do is I start on top and I just want to mark it perfectly symmetrical. So we want it to be exactly in the middle. Because it's easier to glue it when you have this.
Do you mark the inside now as well?
No, not now. But now you can, yeah.
Do you want me to? So there we go. And this is different ways of doing. So what you can do, if you check out the instructions, we have actually shown 3 different ways of doing this. Now we will do the simplest version here now, but you can go all the way up to point where you do it the same way as the huge ones, the big hovercrafts, you know, the ones that drive from UK to France. The same kind of principle as they are using, actually. You can do that.
The key here is that you want a round hole on one side and you want a square hole on the other side, and you don't want it to go, there's different holes on different sides.
Yeah.
So on the other side, I find it easiest to just use two post-it notes because they are the perfect size, but one of them is cut in half, it's like folded in half. And then just overlapping. And then you will be placing it symmetrically in like all directions. So you also have kind of like that, I think. You have 4 centimeters.
From all sides,
Yeah.
basically?
And then 4 from the edge here, and 4 here, and even, I think even here, yeah, approximately 4.
Maybe tilt it a little bit.
So this is why we're showing you how you can do it without the box, because you might do this wrong the first time. So, because accuracy is key here. So, and then...
So what happens if you aren't accurate is that you might find that the hovercraft is tilting a little bit. Now you will probably still be able to drive it, and especially because it has a gyro, so it will stabilize it itself. But like Henning says, accuracy is key here.
So now I'm actually inserted in my hand just because I know that I don't get through, and I will just... I'll just fold it, don't cut my hand, but you just
make sure.
Start at little like fold, and then don't cut too much, don't cut like too long, only to the edge, not beyond the edge.
You want to be quite accurate when you do this.
Yeah.
And like if you cut too much, then like I said before, this is a bag you get at the normal convenience store, so...
Or like office supplies.
Yeah, Staples typically have these kind of things, and then you get like hundreds
so
of them.
That's on one side. On the other side, I will just also make a little like that if I want, and then...
And now the good thing is that you already have a big hole on the other side, so you can actually cut through the whole thing because you already have space to work with. Great.
Yeah.
I think this is warm. Yeah, it's warm.
Yeah. So now it's very important to have the circular hole down into, it will fit around here.
So what you want to do is basically glue that first, right?
Yeah.
So if we remove this now, and we can start gluing it.
But here,
Now, do you want to...
Yeah, there's one key thing, because it can melt through the whole bag. If you just start gluing it now with the hot glue, it can melt through the whole bag. What you do is take a A4 paper, you fold it in two,
and you put
and insert.
That's right. I think I'll clean up here a little bit.
You can even do this before you cut. It might be easier to insert it before you cut it, but anyways, now it's here. And now we will put glue here and then try to...
That's gonna be a little bit tricky.
Let's mark it again, because it's easier now to... I can see my holes, like the markings under, so let's just... If you hold it... because you don't have much time once you start the gluing. You have to be quick. So with the markings, it would help you, be accurate. Because if you miss, it's very hard to go back. You want to kind of like one hit and miss, kind of.
Yeah.
One shot on it.
Yeah, because this glue will melt the bag, actually, a little bit.
Yeah.
For if there are anyone out there who don't have a glue gun, that might happen. Do you recommend some kind of substitute for that, Henning?
For?
If you don't have a glue gun.
Yes, contact adhesive. Contact adhesive is the type that you have on both surfaces first, and then you let it dry for 5 minutes, and then that's actually a bit better in terms of you have a bit more. You can do it slower, kind of. You can do it a bit. You don't have to rush it because the hot glue is getting cold, so you have to be quick. But here you can take a bit more time. But plastic, old glues doesn't work well on this plastic. So contact adhesive works really good. Hot glue works really good, and then super glue might work. But yeah. Yeah.
That's the basic tip that if you go to a store, a hardware store, the type you get with spray usually, that works fine. So now I'll do the circle here first, and after that we will do the outer edge of the raft. And like Henning said, do we actually have more glue here? I think, yeah, we do. Because like I have a little, it's not that much left here, so I just make sure to have another glue stick just ready in case, because like we need to be quite quick here.
Yeah, but you can actually start here.
Yeah. Let's see when it starts coming out here. This one isn't like the best type of glue gun either. There we go. Okay.
And then accuracy, be accurate.
There
symmetrical.
There we go, approximately there.
Yeah.
Then we just squeeze this one really nice and tight in to the fleet. Good. I think that's sticks quite neat onto the surface here. I can actually feel, when I feel the paper, I can feel that it's actually a little bit hot. This is good. This is what you want. And now we need to do the outer surface. And here you can do it like one side at a time. So I'll just first use this one. I will insert the other stick here, I think, because it was so little left. Let's see. Just try to use up all the remains so I can stick the next one in there. There we go, this side finished. So then we just place this one onto it. You can actually use the table now, just. And here's where the paper really comes into picture, because if I were to glue this without the paper in between, I would glue both surfaces. They would be stuck together. So then we can do the front side. Now I need to exchange the glue in the glue gun. So I just see there that it's stuck nicely onto the bag. There we go. And then we do the right side of the raft. like this. And then we only have the back of the raft left. Then just leave that to rest a little bit to cool down. There we go. What's the next thing, Henning?
Battery and servo, and servo is the motors.
Motors are the next thing. So let's find the motors. They are here.
But you need servo before this motor.
Servo before that motor. Yeah, sure. Then we actually can start with the servo. So what we want to do is that we have this one here, and we want to have the servo horn put into this hole like this. And then we take one of the rubber bands. Now I hope this was one of the good ones that you have gotten. And then we stick that on there like this. And like Henning told before, that you actually get this small screw here, but we don't really need it because it's going to fit nicely onto the servo itself.
If you have problems with the tail falling off, after a while you might experience it, and that's when this is really handy. It's really handy if, like, for rough driving and stuff, but only use it after you have, you know how to straighten out the tail fin. So just have it as a backup, but you don't need it for the start.
Yeah. There we go. The rubber bands are placed. I think this one actually can be fitted on the other side of it. But this works for now.
Yeah, or you can do like this also.
Yeah. Then we can place this one. Now we have mounted this one nicely, and here we have some graphics, to show. Yeah, we can do it like this. This probably works, then you can see the 7 and everything. And then you can just click that one right into the cardboard itself. And that will fit nicely. And then I just make sure that it's, let's see this.
Oh, it's not compatible?
Yeah, it's not compatible.
Oh, yeah.
Yeah, then we actually need.
Because you took it from another bag probably, or?
Yeah, something that was here. But, then we actually.
Now it's on. Okay, it was just loose.
If you can hold it.
But wait with the screw, because we need to straighten it out first. We don't know if this is really going to be straight.
Okay.
Because the servo can move when we switch it on. So.
Okay, so we do that afterwards.
Yeah.
But now we are mounted. If this one it will fit for you guys because you don't have misplaced parts. Yeah. So then you actually can do this, and you can just take it off afterwards.
Okay, try this one. Sorry.
No.
No? Okay.
It's okay.
Okay.
It's okay.
Okay.
So next thing, mounting the motors.
Yeah.
Where was this small wooden part?
But wait with this motor.
Wait with this motor.
But this one you can.
Yeah. Then we can just place this one into the frame. This one can be a little bit hard, like it is here. I think I will remove the paper now. Yeah. Let's see if I can. Yeah, if I can remove it. Stuck pretty good in here because of the glue. There we go. So what can happen is that you can get some glue onto the paper, but that's okay. what you want is to have this just through, but you don't want it to like touch the ground when it works. So there we go. Does it matter which one I connect this one to?
No, bottom one.
Bottom one. Okay, then I will put this one here. Like this. And for the server, you can mount that one as well. Do you have any good pointers to like keep this nice and tidy, Henning?
Yeah, you can have it under the board. You can like make it go.
Underneath there, yeah. That's a good idea.
And then kind of go around and...
Yeah, and which one should they connect now? Because there is a difference and you can connect this the wrong way.
Yeah, so the ground needs to be the lower and the orange needs to be... So you have the sun on top and you have the soil on the ground.
Yeah. So that means the yellow one should be at the front of the hovercraft and the brown one is at the back side of the hovercraft, like this.
Yeah.
Cool. Cool. So next step now is that to...
Switch on and straighten out the servo maybe?
Yeah, do we have a battery here somewhere?
Yeah.
There we go. The battery. Then we take a rubber band, like this. Make sure that the wire is on this side so you have enough to move around with. I'm just gonna place this under here. I'm just gonna need to use both my hands for this, I think. Here's also an advantage to have a raft not made out of too big of cardboard, because then you have more space. Now there's a little bit small space here. Let's see, then we can put in...
And one thing we need to point out is that this screw here cannot be too long.
Yeah.
Because it will obstruct the plug, and it can even like squeeze the plug and squeeze the connection in here, so you can actually damage it if this is too far up and you're forcing it. So make sure it's flush, and if it's too long you can actually you can just cut it with a small plier.
Yeah.
Yeah.
Like these ones.
So either you cut it or you insert another spacer so it doesn't stick above the nut here. And then I will just give it the right code before we continue.
Yeah, do that. We can. So if there are any questions now, please feel free to ask them. Yeah, for Facebook.
Remember to
Yeah. So remember to go into Facebook and be part of the group at
you can actually
Go Hoverbit. So you can actually see it now on here we go. So now we are in Facebook, and here you actually see one of the projects that we have been working on. So this is this is a this is not us. This is a fan that have built a hoverbit boat actually. So this is really cool. So then you can run this on water. But if you're going to do this, be aware that the Bluetooth signal are dampened by the water. So in normal conditions like we are in right now here, On ground, it will reach between 50 to 70 meters, depending on, you know, a lot of variations. But on water, that is reduced significantly. So just be aware that you don't like run on into the water, because it might be hard to get like the hovercraft back again if you don't have any redundance, or if you don't know that, you know, it will run until it hits ground somewhere that you can actually go and pick it up. So that's important. So Henning is now adding the code into the hovercraft, the code that we had before. How's that going, Henning?
It's not connecting.
It's not. Okay, it's not, it's not connecting. Do you have a right USB? Because we do have different numbers of USB. Here you have one. Let's see if that works. You get like...
You can also show the catamaran.
Yeah, do we have that here?
Yeah.
Yeah, there it is. So some of you may actually have ordered this on the Indiegogo page. So here is some of the parts for the hoverbit catamarans, and then you actually make the hoverbit into a boat. So these parts here fits like this, and you can then build your own hovercraft, really. No, your hover boat, in fact. So
and actually Stefan is making a 3D printable boat as well now.
yeah, that's why I thought...
Stefan, can you give us the latest news on the boat?
So I hope that he will write in the comment section, or maybe he will actually join us if that's possible. But that's the reason why I thought this might be us, because Stefan is actually working on building a boat and not a catamaran. So that will be interesting to see, and this will of course also be shared in our pages on the file system. So we will have all the files available there. Probably be a project as well. So then you can actually see the whole process of how he has made this boat.
It's transferring now.
Yeah, so now the code is transferring. Now you have already done this, so you don't have to do this one more time. This is just because we made this out of another microbit. So now it's now it should be okay. Do we have a remote for it as well? Yeah, that will. Okay, so let's switch it on and see. Number 7, yeah. So now I see both of them are running actually. So we see here, now if I switch this one on there. So here's the thing that Henning was talking about. When we see this LED here moving, then we know that they are actually in fact connected. That's a good thing. So good, now we know that that's centered, the servo at least. Then we can add on this one, right? Let's see if we can
make sure that you guys see it. So now this is straight. You place it straight.
Yeah. Then we can try to add this one, see if this works. Hope this works. Oh. Well. Not the right tool for the job, but I hope that we will manage to get it in there. Do we have some smaller?
Yeah.
Oh.
But it worked before though. But maybe
Yeah, this is just too big. Let's see if I can manage to. If not, we will have to change this one with a smaller one. Don't try this one, it might work. Okay. Let's see if this works. It's there we go, that seems to be working. So now I will straighten that out, and then we just screw it into the servo. There, it's working. It's working! Yay! Good, it's actually shaking. That's a good thing. Then we can, then we see that it's actually working. We turn it off now and mounting the last motor onto it.
Wedge.
This one?
Wedge first.
Oh, yeah, the wedge. Where's the wedge? There it is. This one. Placing this like you can see here. Then we take the motor and really neatly pushing this one in. This is where you can like apply a little bit of not brute force, but yeah, you can of course use that, but you want to like maneuver it a little bit just to get the right. Let's see, it should be snapping in any moment now. Ah, there we go. So which one is this supposed to go into? The lower one?
Yeah.
Yeah. So I just move the battery a little bit, try to get it in there. I might have to remove the battery to do that. Maybe I can do it without removing the battery. This is like, yeah, I just have to take it a little bit more away. This was there we go. Good. Now, do we have any propellers here?
No.
No, we don't have any propellers that we need. What? Yeah, so what Henning just said was that we now want to just test everything to see that everything actually works the way we want it to. So now I will start up the hovercraft. There we go. It has connected. So it spins around, and then you can just feel the different engines, and you can feel that, yeah, they are vibrating in fact. So that means that they are working. Turning it off, and then to make things a little bit more tightly, what we can do is that we can actually place these wires underneath this rubber band. So what I do is that I remove this rubber band here, and then I place this wire underneath here. There we go. That's a little bit more neatly done, and it also makes sure that the propeller don't come in contact with the wire, because that's something that you don't want. In fact, if that happens, you can damage the wire, so the motor doesn't work anymore. Now we have some propellers here. Does it matter which one?
Yes, but you can just try and see.
Yeah, okay, then we just try and see.
Don't put it on too hard, because.
Okay, now we put it
on.
on.
Mount it first.
Now we have loosely mounted it, and we can just test if it's the right way.
So let's see if it's blowing the paper this way or this way.
So is it time for... Seems to be the right way.
Yeah.
Yeah, definitely the right way. That's good. Good. So then we turn it off once more. It's always...
Then you want the opposite kind of the under.
Yeah.
Right.
So this...
You can test this as well.
You can see this here. I don't know if you can see this good, but like they are the opposite of each other.
You can also put them on the table and just blow on them and see which way they spin. So on something like a flat surface.
Yeah, that didn't work at all, but yeah.
So this is a counter. Clockwise also says on the with the small letters here, CCV. That's counter. You will, on the top. What does it say on the top?
It's CV.
Yeah. So you want CV on top and CCV on the bottom.
Yeah, that's correct. Now, one issue that you can encounter, and this is a good thing to check before you do like the first flight, is that you want to see that the propeller is going on nicely. Now here you can see that it's actually touching here. So this is something that I will improve right away. Just make sure that the propeller can move freely. Just take the knife and make the hole a little bit bigger. Make sure not to cut too much. Like now there are electrical wires and stuff on top, so you want to be a little bit careful doing this. So then I remove the piece. Let's see. Seems to be here a little bit, touching there. Then I will remove that part as well. Like this. Let's see. Yeah, now it's only a little bit of plastic here, but that really doesn't matter that much. The plastic isn't going to stop the propeller anyway. There we go. Now, I think that we might be ready for a test run. And this is something that we have all been looking forward to. Let's see if it works. Now, I need for you to be able to see this, I will just hold it like this and we'll see. Let's see. This didn't start at all. There we go. So it's lifting up, yeah, seems to be working. So this is pushing now. So I need to like hold it back for it not to move forward. And it seems to be working. Now I can move it all around on the floor. And then the shake function to make it stop. So now I hope you have done the same thing as we have done. And I hope that your hovercraft is working. Can we see in the comment section if everyone has finished also their hovercraft? Because now we will try to do a demo on the floor with this one.
Yes.
Everyone is ready. Then we will do a demonstration on the floor. Let's see. Now I'm...
Bara skruva upp musiken här lite.
So now
Just one thing. Hvor er lyden?
Like,
The shaking is because the tail is kind of heavier than normal, and it will actually introduce some movement noise into the sensors. So it's kind of overcompensating right now. So to combat this, you can actually make your tail smaller or just stop it. But you can actually trim it down a little bit, or use thinner cardboard, something with less weight, and then it would go away.
yeah. Okay, now we'll try to make it run.
Is it balanced? Yeah, I think it looks balanced. So this is the key. It's like it's supposed to look balanced. So you can show, if you can show like a skew, if you stop it, if we take it here. If it's like this or like this, then it will not like perform very good. Then it means that it's out. It's not like symmetrical. So if it drives like this, I recommend you try again to make a new raft and try to be more symmetrical. Or you can add some counterweights. You can add a little bit weight on the opposite side, but this will make it heavier. So the best thing is to just try again and just try to make the raft better and more symmetrical.
Yeah. So this one, like Henning says, it's balanced. One other thing that I noticed, and this one will run pretty smooth. But one thing I noticed is that the back here was open. So
Yeah,
we can
it will run better with it closed.
Yeah, so we'll try to close this one now. Oh, it's kind of hard to make it. There we go. Now I hope it's closed. And we can try to go for another test run. Let's see.
Yeah. All right.
Yes,
It works.
good.
Um,
And I hope that your result is just as good as ours. If you've done something in particular, or maybe just we would just recommend sharing the project really.
yeah.
It's important to like show others what you can do, it's very cool to be able to see what others are doing with their hovercraft. So,
Race tracks, for example.
yeah, and like this is a cool way to drift. That's like I think that's one of the coolest thing with this one is that it's a natural drifter. if that's allowed to say, but you know, doing corners, stuff like that's really cool. And like Henning said, the racetrack, very cool thing to do. And also, if there is if you have any questions about anything regarding to the hovercraft, we recommend using the Facebook page. Go Hoverbit on Facebook. Using that for support, it's super good that also others can see the answers to maybe what you are wondering about also. So then we have built the hovercraft, we have coded it, and now it's time to just continue to develop it, whether it's a boat, whether it's to do something that runs faster on some certain terrain, a perfect drifter, whatever the project is, keep on working on it, keep on coding. Mm? Yeah. And this card, like Henning said before, is actually the Airbit card, so you can check that out if you haven't already seen it. Basically, thank you so much for watching this event, and thank you so much for supporting the Indiegogo campaign. This is so important to us, and we really hope that you are just having a great time with this hovercraft. So, is there anything else that we should mention? Any questions?
Yeah, so if you got guys any late questions, or you can email them, or you can post them on Facebook after this. It will be available. This recording will also be available to you guys.
Yeah.
And also check out the videos that Stefan made. They're very like hands-on, very easy to understand. And
it shows the whole process really, step to step. Thank you so much for watching. Have some great fun with your hovercraft, and
bye.
Bye bye. Thank you. I fix it.